Okay, everyone, it's 10 o'clock, so I think we're going to get started here. Before I introduce Dan McLean, who's the CEO of the Ptrc, I would just like to let people know kind of how this is working. If you put your cursor to the bottom of your screen on Zoom, you will see there is a Q&A tab as well as a chat tab. Now, the chat has been enabled only for attendees like yourselves to ask questions of the panelists. You can't speak to one another. You do that on Zoom because, you know, there's been examples of people bombing Zoom meetings and posting all kinds of weird things to people. We don't want that happening. So you can send questions to the panelists either through the chat room, or you can do it through the Q&A at the bottom. You also, there's no anonymous questions because we want to be able to follow up in case we don't get to your questions at the end of the webinar. The way this is structured, 4 presentations will be given, and then we're hoping to have about 15 minutes at the end to answer direct questions. Those questions will be from the written text, and we will ask them for you. So please, if you have questions, either put them into the chat or put them into the Q&A. We won't be opening up speaking for people. That's just too much of a risk, and with these kinds of numbers, you know, we're already up to over 60 people attending, and it's important, I think, to maintain some control over this. So we welcome all your questions, and by the way, there's also a raise hand feature in the chat. Don't bother using that. I mean, we will keep track of that, so if someone raises their hand and they have a question, it's just better to type in your question directly, and we're making a list of those questions, and hopefully we'll get to it. If we don't, we will respond as a written response to you after the webinar is over. Okay, Dan, would you like to introduce yourself and the speakers?
Yes, thank you very much, Norm, and welcome to everyone on this webinar. Thank you for taking the time out of your very busy schedules to participate in this, which seems to be the normal forum for communicating these days. Just a couple things at the beginning. You know, we're in the throes of a pandemic, which is probably the single most important thing that affects all of our lives today. And we're fully aware of that. It affects our lives and how we work. And but stuff still needs to get done. And so we saw this as an opportunity to reach out to a large audience to share with you some of the things that we do. So before I get going, I wanted to say welcome to everyone. Welcome to folks across the province of Saskatchewan. I know we have folks from Estevan, Weyburn, and Lloydminster, in particular the Office of the Mayor of Lloydminster. Welcome to you folks. And we also have quite a reach into the rest of Canada, Alberta, and other provinces, and internationally. We have folks from around the world. And so welcome to all of you. We hope that this will be interesting and maybe somewhat entertaining. It is a very high level overview of some of the things we do, but also about our industry here. So before we get going, I just want to tell you a little bit about the Ptrc. We've been around for well over 22 years. We came together as a result of an arrangement with the province of Saskatchewan and the federal government to support research in oil and gas. We are also committed to supporting research organizations here in Saskatchewan, from the SRC, and welcome to Petro, as well as the University of Regina and University of Saskatchewan. We have basically 3 areas of research that we have been involved in over the years. They are, I like to refer to them as quite progressive in nature. We've been involved in this carbon capture, utilization, and storage category for quite some time, in particular around CO2. In the early 2000s through till 2016, we were the lead research coordinator for everything related to the Weyburn CO2 EOR project, where we made sure that the CO2 was in the ground doing what it was supposed to do. We call it measurement, monitoring, and verification. From there, we went on to become the coordinator of all the research in Aquastore. Aquastore is a CO2 storage project connected to the Boundary Dam coal-fired power generation plant, which has carbon capture on it, and we're involved in that. And we're also involved in heavy oil research, in particular in the Lloydminster area, related to cold heavy oil production with sand. We have researchers from Saskatchewan and industry who support that activity. So we've been around for quite some time in very many areas of research, and we're looking forward to moving forward, continually to being progressive, ahead of the curve as it pertains to supporting the sustainability of this resource industry here in Saskatchewan, and in particular in reducing greenhouse gas emissions, which is something that we have been involved in for quite some time. So that's the PTRC. I want to also introduce to you now the folks who are going to be speaking today, starting with Eric Nickel, who is our Director of Projects at PTRC. We have Petro Nakutny from SRC, he's here. Erica Emery, she's here. Is Suzanne Johnson, is she going to be speaking also? I can't remember. Nope, okay, well, we've got two other folks from SRC, Matt Nasehi and Zanab Movahedzadat, they're also here. And I'm going to turn it back over to Norm Sakuda, who is going to be our facilitator for all of this. So thank you all for coming, and I hope you enjoy this.
Okay, thank you, Dan. So yes, there is 4 presentations today. I'll deal with that and their order right at the end of my short presentation. Mine is a real basic introduction that I'm going to talk about, and then we will move on to the other 3 speakers in order. So now I got to see if I can share my screen here. There it is. There we go. Can you all see that? Good. Okay. So this is just a real basic overview of oil and gas in Saskatchewan. And as a matter of fact, it really talks more about how things get started with oil and gas. Eric, who's following me, will be talking about the nitty gritty of things like oil wells and things like that. But I'm just going to talk generally about what it takes to start the oil and gas exploitation or development industry in Saskatchewan. So first, my outline. So I'm going to provide some key definitions for oil and gas. This isn't just going to be coming from me. You're going to find these throughout the presentations from all 4 of our speakers today, but I've got some particular ones that I want to tell you a bit about. Then I'm going to talk, as I say, about getting started. I'm going to talk about what crown rights are and what land sales and leases are. And then I'm going to talk about freehold rights for minerals and for oil and gas in Saskatchewan, so that way you're just aware of how it works in the province in terms of starting the production of oil. Then I'm going to talk about the benefits of oil and gas in Saskatchewan, a quick overview, and then I'm going to talk about some of the challenges, because of course, with concerns about climate change happening across Canada, the oil and gas industry has been a particular focus of that, both of criticisms and of development. So I'm going to talk a little bit about that, and so will our speakers after I've done a bit of an introduction. So a few of the definitions. First of all, if you go to the PTRC page, this is a link. We can send this link out to people after the presentations are over. We have a glossary of terms at the PTRC. Now, we've been working on this for only about the last 8 to 10 months. It's been populated with some good definitions right across the industry. So if you ever have a question about a particular thing, like an oil well, or what is CHOPS, for example, which is cold heavy oil production with sand, they will be included in this glossary. So just make note of that. You can go to the PTRC page. That glossary will be world class within a year, I promise. But right now we're populating it with some material, and it's a good start. So 3 of these definitions right off the bat are called upstream, midstream, and downstream oil and gas. Some of you may have heard these definitions in the past, but I'm going to provide a better definition. So upstream oil and gas is the idea of actually drilling the wells. What happens at the wellhead? What happens in the field to get the oil and gas out of the ground? So when we talk about upstream oil and gas, we're talking about the aspects of the industry that are about exploration, about production, recovery from reservoirs. So that's upstream oil and gas. Midstream oil and gas, you could consider to be, although it's some other things, the transportation of materials. So how you get that to market, you might even say that big tankers going across the ocean, pipelines, that's midstream oil and gas. How do you get that to locations where it can then be further refined and upgraded? So that's what downstream oil and gas is. It's the refining to finished products, and frankly, the sale of those products. So when we're talking about upstream, midstream, and downstream oil and gas, which is often talked about right across the industry and in the general public, those are the 3 things that we're talking about. The PTRC and I would say SRC are most heavily involved with upstream oil and gas, although SRC, because they're interested in pipe flow and in improving the abilities of pipelines to do what they're supposed to, are also involved in a significant way with midstream oil and gas. So definitions as well. OOIP, sometimes you'll see this used quite a bit. It's actually original oil in place. When you discover a reservoir, so I'm going to use the example of the Weyburn Field for this. When the Weyburn Field was first discovered in the 1950s, and they did all the characterization, and they looked at all the seismic records and were able to determine how much oil was down there, the original oil in place was 1.4 billion barrels. Now that's a great reservoir. That's a lot of oil. It's a world-class reservoir, and this is in southern Saskatchewan. Since 1958, I believe, or it might be 54, I've got my dates mixed up, they've started to produce oil from this reservoir of the 1.4 billion barrels in place. Now, when we talk about reserves, that's the number of barrels of oil that you could get out of that reservoir given existing technology. So just because there's 1.4 billion barrels in place there, that doesn't mean that the reserves are 1.4 billion barrel. What are the reserves? Well, at Weyburn, it's been variable. Initially, they thought they could get about 350 million barrels out. And as a matter of fact, by the year 2000, they'd gotten around 300 million barrels out of the reservoir. But it wasn't until enhanced oil recovery came around that they got beyond that. Now, ever since CO2 has been used at the Weyburn Field, they've gone well past the initial 300 million barrels of oil coming out of there. And right now they're sitting at about 500 million barrels. That's because of CO2 being used in the reservoir. So when we talk about recovery rate, which is the third term here, that's the number of barrels that have been recovered versus the amount that's in the reservoir. So right now we're talking about a 36% recovery rate at Weyburn, around 36%. Now, what is enhanced oil recovery? And this is something that's going to be covered off by the next two presenters, by both Eric and Petro. But a brief summary is that it's technologies that come on stream that are used to continue to produce oil from that reservoir. And it's thought that at Weyburn, at the very minimum, we might get another 200 million barrels because of those new technologies, which means we are approaching or will be surpassing 50% recovery from the Weyburn field. That's very possible. That is amazing recovery. A lot of oil reservoirs, you're lucky if you get 5, 10, 20% of the oil in place because it's, pressures drop, you're just not able to get any more oil out of the reservoir. So Weyburn has become a really world-class field that is being looked at. And I used it to basically provide examples of what these terms mean for you, if you're interested in looking them up further. Okay, so let's talk about Crown rights and ownership. So basically, the government, or Crown as it's called, so the provincial government of Saskatchewan owns the mineral rights to the vast majority of locations on the province. About 80% of the mineral rights, so that is what is underground below your land, is owned by the Saskatchewan government. Now that doesn't just include oil and gas, that includes potash, increasingly really valuable commodities like lithium. The province is looking more and more at lithium because, of course, those are used in batteries to power cars, things like that. And they are finding that there's lithium in some of the underground reservoirs where oil and gas is, or where there's deep saline reservoirs. That's also being talked about. There's also helium. That's another commodity that's underground. And we actually have a helium production plant now in southwest Saskatchewan because they were able to find helium in some of these underground locations. Now, as I've said, most of those rights are owned by the province. And the province decides to do what's called land leases and sales. And what they do is they make public offerings or notices that are posted at the Ministry of the Environment site that says this particular section of the province or this particular area is now up for lease or up for sale for exploitation. That is, if they haven't already put it up for sale or for lease. What happens then is usually larger companies. It's hard if it involves oil and gas for it to be a smaller company to do these kinds of bids. Makes a bid and says, we want to purchase the rights to exploit this particular resource in that area, and we're willing to pay this amount of money. The top bidder usually wins. As I've said, if it involves oil and gas or a large area that requires a lot of infrastructure or pipelines or pump jacks eventually, it will be a larger company. That doesn't mean that obviously smaller companies can't make bids if it's smaller parcels of land, and that certainly has happened. Now, when that's sold, the rights to exploit that, there is a limited time for that company after they've paid the money to the Saskatchewan government to be able to exploit that resource. If they don't do it within, let's say, there's different windows, but 2 to 5 years, the rights go back to the province and they're able to put it back up for sale again because the company was not successful in being able to actually exploit it. So these land sales and leases are handled. If you're interested in how this works, you can visit this website that's here at the bottom. I will also send this link to people. Provides a lot of valuable information about how it works. So royalties, that's another thing that comes out of this. So aside from selling the land leases to companies, the oil that gets produced from these when the oil starts to flow, also because it's owned by the province, these companies have to pay royalties to the province. Now, what percentage of royalty is paid? And that's where this document here kind of sets out some of the rules for that. And it's variable and it's always changing, because oil that comes out of the heavy oil reservoirs is harder to get out of the ground. There's less of it that comes out. The royalty rates for that might be less than an oil field like Weyburn, where it's a medium crude, it's easier to get it out of the ground, and a royalty rate as high as 18 to 20% of the value of that oil might be paid to the government. A much smaller, you can have with horizontal wells that have been drilled into some of the formations like the Bakken, which are very expensive wells. Usually the government will allow a very low royalty rate until that capital expenditure has been paid back to the through oil sales to the particular company that did the well. So you might only have a 1% royalty rate. But as soon as that well is paid for, the royalty rates go up to like 15, 20%. So let's say an average for the province might be between 10 and 20% royalty rate, which is paid into the coffers of the provincial government on the basis of sales of the oil that gets exploited from those reservoirs. So what's freehold rights? About 17% of the oil and gas and other mineral rights that are owned in the province are owned by individual landowners, and those are freehold rights. So for example, if you've ever been down to Estevan or to Weyburn and there's a farmer who looks really wealthy with his property and his huge house, it may be that that farmer owns the mineral rights under his property. And so when the oil and gas has been exploited, even though the sale of that particular region is handled by the government, and the company that is determined to go in and do that is also determined by the government, that company still has to pay royalty rights to the landowner that owns the minerals underneath it, if they own the mineral rights. So that's the first thing. And I mean, if you're a oil and gas producer and owner, and you're a landowner, you might get 1 to 4% of the value of the oil under your property. And if you're producing thousands of barrels a month, that can be a lot of money coming into your coffers simply by allowing a company to come in and exploit it. So that's what individual landowners and freehold rights are about. There's also a second kind of right, and it's here for payment for surface rights. So even if you don't own the mineral rights underneath your property, you are still able to ask, if the oil company wants to come in and put a well on your property, you're able to ask for a yearly rate for renting that surface. And that is paid by oil companies to every landowner who has parts of their land disrupted by having an oil well there. And that fee can vary widely. And it really is dependent upon how many wells are on the property, how much land is being used, and what the production is from those particular wells. Some of them aren't going to be producing very well, so you might not make very much for surface rights. And by the way, a landowner who doesn't own mineral rights can choose not to have any access to his surface rights. There can be some challenging of that on the part of the oil company if they really feel they need to have access to that land, but that is usually moderated by the government at a tribunal that they would hold between the company and the landowner. But landowners can refuse if they want to have access to their properties. So what are the benefits for Saskatchewan of oil and gas? Well, there's some basic ones, and these are also available at that website that I noticed that I put at the bottom of the previous page. In this 2019, there was a trailing off of oil and gas production a bit because of the prices falling and because of other issues. So there was 180 million barrels of oil produced in Saskatchewan in 2019. The value of that was around $10.5 billion. The prices fluctuated widely over the course of the year, so that's a rough estimate. But there is a line item in the budget for 2019 that indicates $691 million was provided in royalties to the province. Now, just for context, because there's other mineral rights coming in for potash, even for lithium, I don't know, probably not much for lithium at the moment, but potash provided 619 million in the same year. So those two resources and the payment of royalties brought in about $1.2 billion for the Saskatchewan government. There's also 32,500 people in 2019 directly employed in oil and gas. And by directly, we mean people on rigs, people directly involved with trucking in relation to those sites, people in offices in Lloydminster who might be working for Husky. Direct employment was 32,500 in Saskatchewan. But there's also significant benefits of indirect employment. And for this, I'll just mention that the Ptrc, although the Aquastore project is not about oil and gas exploitation, when we go down to do well work or when we go down to do monitoring or measurement in the Estevan area, we're often using local industries like accommodations, like food, clothing supply companies, even other kinds of trucking. We've even rented snowmobiles down there. So those kinds of spin benefits are also a part of the benefits of oil and gas in Saskatchewan. So what are the challenges? And these are significant challenges. And the reason I'm putting them here is because in many ways, our three speakers after me are going to be talking about these because they are challenges for the industry. The first is, of course, greenhouse gas emissions during the production of oil and gas. So aside from what might get produced in terms of CO2 emissions from the burning of oil or from gasoline and those things, the production of oil and gas also can produce a number of emissions. So for example, when you're using steam-assisted gravity drainage, which is one of the methods of injecting steam into heavy oil at depth in order to get the oil to move back to the surface, you have to burn natural gas or some other source in order to produce the steam at the surface that goes underground. So the CO2 emissions from that process are part of the overall emissions footprint of oil and gas. So that's an issue. Can we eliminate SAGD, or can we at least reduce its effects? That's one of the things that PTRC is looking at. Methane emissions, fugitive emissions, they're sometimes called, from oil and gas production. Those are an issue. And methane, as Erica is going to describe, is a much more difficult problem and also a much more demanding problem in the oil and gas industry because the effects of methane are much more profound than CO2. Land disturbance. So what we're trying to do at PTRC is one of our many of our projects is to really optimize the amount of oil you get out of a single well. If that well runs dry, you have to drill another one, which means more well disturbance. So if we can help optimize wells, then we'll have less land disturbance, less need to produce. And then finally, water use. And that includes the injection of water, which is a common process into wells in order to increase the pressure within them. Often the injection of water isn't from surface locations, but from salt and water, they're called aquifers, at depth, which you then pump up and inject into the reservoir. So, and where you are using surface water, to eliminate that entirely would be the ultimate goal, I think, but rather to use water that's used at depth and at other locations. And of course, you don't want any of that very salty water being spilled at the wellhead. So that's another issue that is potentially to be looked at. So that's it for me. And just brief summary of what's coming up with the presentations. Eric Nichols going to be doing the basics about wells, how they're drilled, what's an oil reservoir, where are oil and gas located, and also touching upon enhanced oil recovery. We have Petro, he's going to be talking about EOR, enhanced oil recovery, and IOR, which is improved oil recovery, and also a number of definitions and other background information and information on the research that's being conducted at SRC. And finally, we have Erica. She's going to be talking about methane and the research work that's being done at SRC to help mitigate some of those emissions, and also kind of a summary about why methane is a particular problem. So with that, I'm going to stop sharing, and Eric, please go ahead and start with your presentation.
Thank you very much, Norm. I hope everyone can see my screen. I'm going to talk about a little more of the technical stuff than what Norm was talking about. That was a good background. Thank you very much, Norm. Consider this sort of continuing to drink from the fire hose on all things oil and gas in Saskatchewan. So I'm going to go through some petroleum geology basics of porosity, reservoirs, fluids within them, and where the reservoirs are in Saskatchewan, how you drill an oil well and what that looks like in cross-section. Also, reservoir depletion and EOR. I'll touch on EOR. Petro's going to really get into it a little bit deeper. So reservoir rock. You know, we often talk about rock. I'm a geologist by training. I grew up looking at rocks and talking about rocks. There's different kinds as it pertains to a petroleum geologist. There's the kind that has no pore spaces, real heavy, dense rock. Think of a curling rock or something like that, but more likely a shale, something that fluids can't travel through. But then you have this, the porous and permeable rock. And that's what you have oil and gas trapped in. If we were to take that little diagram and put it on its side and put oil down here, what you would have is basically an oil reservoir. You have rock that is connected pore spaces and porous and permeable like a sponge right underneath real dense, heavy rock. What does this look like in reality? This is a core of a limestone that has these big porous holes in it. It looks like Swiss cheese, although it also may look like a sandstone that all the spaces between the grains of sand are all filled with oil. Some of you may be old enough to remember this. This is Jed Clampett out one day shooting for some food, and up through the ground came the bubbling crude. Not really the way things actually work. Nor when we talk about an oil pool. I know that's our definition of this, and we shouldn't be calling it an oil pool. Many of you maybe think of an oil pool as this pool sitting in a cave underground that we stick a pipe in like a straw in your Slurpee and suck it out of the ground. Unfortunately, no, that's not that easy either. What we do have when we have an oil and gas reservoir are the interplay and the interconnectedness of those different types of rocks. So think of this piece of rock here as that Swiss cheese rock, that real permeable stuff, and this is that real dense rock. But what you would have is fluids, sometimes oil and gas, flowing up through these rocks and finding themselves trapped in a position like this under what's called an anticlinal fold, but in different ways, oil and gas can be trapped in these rocks. And that's what we look for in Saskatchewan. So to access that, we have to drill an oil well. And at its most basic, I could get into all these terms, but really what you need to know about an oil well is that you drill a well and you cement a metal pipe into it, and then you drill a little bit smaller and you cement another pipe into it called the surface casing, then possibly an intermediate casing, and then production casing. Each one is a pipe inside a pipe inside a pipe, each one getting progressively deeper, and each one using a lot of cement. So if you've ever wondered why cement companies are so important to the oil and gas industry, that's why. At the end of it, when you have this oil well drilled deeply into the earth, this is not to scale at all, this could be up to 10,000 feet or 3,000 meters deep. What you would do is go down here and then use what's called a perforating gun to perforate a hole into the side of this casing so that the oil can flow into the oil well. And it won't flow up to surface usually, especially in Saskatchewan. You need to have a pump, and a pump runs on a big long, you've seen these nodding donkeys in the field a lot, but what you have to know is that there's what's called a sucker rod that goes all the way to the bottom of this well, which might be kilometers deep. It's a very long rod, and at the bottom is a valve that allows you to start slowly and gradually bringing up oil to the surface where the gas is separated right basically at the wellhead, and you have oil production. So very many pipes and very many long pieces of steel, as I'm sure you've seen in the yards and on the trucks around Estevan and Lloydminster and Swift Current. Where is the oil in Saskatchewan? Well, it's all in these special places where we have those traps, those special position of rocks where oil can trap. And where that happens to be is in Estevan, the Shaunavon Formation in Swift Current, the Viking Formation in the Kindersley area, and heavy oil up near Lloydminster. Of course, a whole bunch to the west of us in Alberta as well. But what we have here, at petroleum geology at its most basic is we're looking for these sort of wedges of sedimentary rocks, those rocks that could be porous like sponges, sitting on top of what you know as the Precambrian shield. If you've ever been to the lakes up near La Ronge or something, you see a lot of rocks at surface. That's the shield. The shield goes very deep underneath us here in Regina, and between us and the shield is thousands of meters of porous or non-porous rock that we look for traps in. So as the oil well, we drill it and it starts producing. That's really great. This is an example from a place called Steelman in southeast Saskatchewan, and it's a field that's currently owned by CNRL. I think has been for a long time. It was first drilled in 1954. If you look at this production graph, and immediately production started going very high, and by the mid-1960s, that field was producing over 20,000 barrels of oil a day. Really good. Must have been really nice there in the 60s. Lots of money coming in and all that. But in a very predictable and steady way, we see oil fields and sometimes individual oil wells start to dry up or decline in a very predictable way, and with this very characteristic shape of the curve as we get up to 2016. Also, at the same time as that, this blue line represents the production of water. And I just superimposed this upon it as an estimate, but towards the end of the field's life, you'll see that it produces much more water than it does oil, and the company becomes an water handling company more than they are an oil company. And the price per barrel of water is not very good. So all of this water gets pumped back down into different wells and trying to get more oil out. In southeast Saskatchewan, we maybe get 20 to 30% of the original oil in place, if you remember that term that Norm told you. But it can be as little as 5 to 10%. So imagine 95% of the oil remaining in this reservoir. What can we do of that? And it's typical of many fields in Saskatchewan, be they Bakken fields or up near Lloydminster and heavy oil. So we're leaving 95%, up to 95% of it behind. Here's Weyburn. Weyburn had a very similar history. Steady production inclined to the mid-60s and almost 50,000 barrels a day. And then there's this very predictable decline again. But they did something different. They put in infill wells, so that can get you a little more production. They started to do horizontal drilling, and that was a big technology that I was involved in the earliest days in the mid-90s to drill horizontal wells at Weyburn, and that increased production. But most importantly, what they did was enhanced oil recovery using CO2, and that's all this part here. And right by now, although this graph is a little old, they're producing oil at a rate not seen since the mid-1970s, and helping the environment while they do it. So we're going to get into a little more detail on that. What is enhanced oil recovery? So when the field has declined and it's not producing much anymore, you would have a setup of injection wells and production wells, and Petro's going to get into much more detail about this, but you might want to inject water into that injection well and push more oil towards a production well. That's the cheapest and most basic. If you want the water to be a little bit thicker, you could add a polymer to it, and that makes it more efficient, the sweep. You could add a surfactant, and that's a fancy industrial term for soap. And soap, just like it does on your dishes, it will clean grease out of an oil out of a reservoir in the same way. CO2 EOR would be something under gases and solvents. So you inject a gas, maybe methane, maybe CO2, maybe a combination of them. It changes the composition of the oil to make it thinner and run up to the production well better. You can use heat-related technologies like steam. You've heard of SAGD and probably have seen those big steam generators near Lloydminster. That thins the oil and creates better surface tension. And surface tension is a term that Petro will go into a little more detail. Also, you can inject things like oxygen in there and light the thing on fire and essentially burn the reservoir to drive hot oil towards the production well. Lots of things like this. But it has to be economic, and it has to be done economically and in a way that optimizes production and doesn't harm the environment, but in fact improves it. We talk a lot about CO2 at the Ptrc, and we talk about tons of CO2 as they are captured from either the Boundary Dam power plant, but they can also be captured from cement plants or fertilizer plants or ethanol plants. And what is a ton of CO2 look like? Well, a ton of CO2 is about the size of your house, or the size of a small house. A 27-foot cube of CO2 is a ton. You and your family, and me and my family, most of us here, will create about 7 to 8 tons of CO2 per year, just as our natural footprint. But we can take that CO2, if we can capture some of the CO2 that we use from power, for example, at the Boundary Dam power plant, we can start to use that to inject into an oil reservoir. 1 ton of CO2 at Weyburn creates 3 extra barrels of oil beyond what we would have gotten otherwise. Now you're saying, okay, but those barrels of oil create more CO2. How does that work? Yes, indeed they do. Each barrel will have about 400, half a ton, about 400 kilograms of CO2 when it's refined and used. But this is a much lower intensity than any other oil produced. And this is a fairly complicated calculation, but one that makes sense. And if you're interested in more detail on this, I encourage you to Google Azalina 2016 wrote a paper called How Green Is My Oil, which sort of ranks the different production methods as to their carbon intensity. And CO2 EOR is one of the lowest intensity methods of improving oil recovery. One of the benefits of it is that the existing infrastructure, the wells and tanks and all of that, can be used. We don't need to drill that many extra wells. We don't need to disturb more land. Upfront capital is high, though, on this, and it's a very serious calculation to make when you enter into a CO2 EOR scheme. Is it going to pay off in the long run? And often payoff isn't for years. It's a big problem that we have to solve. This is a map of oil wells in the Lloydminster area. Lloydminster is right in the middle here. And oil wells, you can see there's thousands of them. Each little dot represents an oil well. Black ones are abandoned. Those are the ones that are no longer producing anymore, and they've been filled with cement and closed off and cut off below the plow depth of whatever field they were on. The green ones are great. They're producing. They're continuing to drive our economy. The red ones are a little scary, and there's a lot of them. They're suspended. The oil companies have decided to shut them in, basically not produce them because it's not economic right now and they can't get any more oil out of them. But they are there and they're waiting to access that extra 95% of oil if we can do it. And one of the ways we're looking to do that is with CO2. So some of the takeaways from my presentation: don't think of oil pools as underground lakes. Think of them as sponges of rock. Oil wells can be complicated things. Think a lot of cement and a lot of tubes inside of tubes, and highly technological things. Oil production declines in a pretty predictable way, and we're here to try to keep that from happening. We can do that with enhanced oil recovery using CO2, which can help satisfy some greenhouse gas goals while helping our economy and protecting the industry. Many wells in the province are ready to use this, but it has to be economic, and it has to be made economic. And we're looking for ways to do just that. So going into a little bit more detail will be Ptrc, who's going to speak right now. So I'll now turn it over to Ptrc.
Good morning, everybody. Can you see my presentation? Okay. So as Eric introduced you to some of the basic concepts, and he spoke about some of the EOR methods, I will get a little more in detail. I'll try not to bore you with too much detail. I tend to get excited about these things, which my wife does not understand, but it's a chance for me to introduce more general audience to some of the concepts. Before I get into enhanced oil recovery, I just wanted to introduce a couple more terms. And the first term is oil and gas reserves. So what I wanted to point out here is Canada has second or third largest reserves of oil in the world. And so we're sitting on a tremendous resource here that we can, we can use to our benefit and to the benefit of people around the world. And there's a lot of science that goes into oil recovery. Another term that I wanted to introduce you to is recoverable reserves. So just because we have the oil under the ground does not mean that it can be produced easily. So the oil in place is always much higher than what is technically feasible to recover. And that's even yet higher than what is economically feasible. So as Eric mentioned before, sometimes up to 95% of oil stays in the ground. That's because it's either technically or economically unfeasible to recover. And so at SRC and as well as universities and many other researchers in Canada, we are trying to find ways to recover that oil while reducing the environmental impact. So there are three different main stages of oil recovery. And again, you have seen that on Eric's slides for Weyburn Field and others. When we're just starting to produce oil from a particular field, we call that primary production. So that is done by using natural energy of the reservoir. We drill a well, and sometimes there's enough pressure that the oil comes out on its own. Most of the time, especially in Canada, we have to pump it out. But we do not need to inject or do anything else about the reservoir. So it's basically just sucking the oil out of that sponge that Eric was talking about. And again, we can get up to 30% of oil in the best case scenario, but more often it's more like 5 to 10%. Second step is, again, what's been done a lot in Saskatchewan, in Canada, in the world, is secondary recovery, where we inject in water to maintain pressure and chase that oil out. And then once that's exhausted, when we produce mostly water, we go to tertiary, where we try to do something different, such as injecting soap or heating the reservoir, again, to produce even more oil. So why this is important? Well, again, Eric talked about significant decline in production. A lot of fields in Saskatchewan are mature. A lot of wells are suspended. Right now, for example, for Bakken, most of the production is through primary. And we keep on drilling new wells, but even though the number of wells is going up, this orange line, the production has started to decline. So the problem is not only leaving oil in the ground, but also having to drill more wells. So what can be done about that? Well, there's several ways. You can try to improve production by optimizing the current existing pumps, pumping methods, drilling methods, like drilling longer wells, horizontal wells, drilling more wells from one pad, which minimizes land disturbance. But it could also inject different fluids or energy into the reservoir, which would then constitute enhanced oil recovery. And again, that could be gas, could be chemicals, could be steam, even microbes. It's a couple of things that I wanted to mention about primary depletion. You, again, would have heard us use the term cold heavy oil production is sand. So what this is that we allow some sand to be produced from the reservoir. Some reservoirs are not very consolidated. So when you produce oil, you get some sand out, and that creates these conduits that are called wormholes, because that's, they look like that. They can be up to 100 meters long and a few centimeters in diameter, and that allows us to access oil from further away, but that also makes it more difficult to produce oil at the end of primary. And another method that you've probably heard about is introducing fractures, that is injecting water, most often it's water and sand, and creating small fractures around your injection and production wells, and that allows you to access the reservoir. And that is usually done in very consolidated rocks, so they look almost like a granite countertop that you cannot get the oil out of it other ways. So what are some of the enhanced oil recovery, or how we can produce more oil from existing wells? Again, because that would be an ideal scenario if you don't have to drill more wells, minimize land disturbance, and use the reserves, the resource that we have. So one way is to, again, inject something to displace soil out. That could be water, could be CO2 or other gas. The problem is that the oil and water don't mix very well. If you ever try to make salad dressing, you know that you have to shake it very hard for it to mix, and then it settles out anyway. And that is because of this phenomenon that's called interfacial tension. Here you can see this little bug on the water. The reason it can walk on the water is because of interfacial tension phenomena. And so the way we can deal with that is by adding some soap, or reducing or adding actually something like baking soda, because that reacts with the oil, and that creates a soap in situ. CO2 can actually dissolve in oil, and in some conditions it can remove interfacial tension. Yet another way of producing more oil is to reduce oil viscosity. And that could be done by increasing temperature, injecting solvent, such as hydrocarbon solvent, or again, CO2 can do that. And then we can also try to improve permeability of the reservoir by fracking, or doing some acid treatments or sand production. So you have seen in my previous slide, and also in Eric's presentation, that we talk a lot about CO2. And that is not only because we want to reduce the environmental impact by putting CO2 in the reservoir, but also because CO2 is actually pretty good in recovering oil. And again, Weyburn Field is one of the good examples. The reason it's good at recovering oil is that it can dissolve in oil and swell it. If you ever opened a pop bottle after it's been shaken, you would know that it introduces a lot of energy. And that's what can happen in the reservoir too. If you inject CO2, pressurize it, and then basically open the bottle, it can all come out, both CO2 and the oil, although some CO2 will stay in the ground. And again, there are different ways of introducing CO2. It depends on pressure and temperature. So there are two main processes that could be used with gas or water to add energy to the reservoir. One is cyclic CO2 or gas injection, where we inject, then we soak, then we produce. In this case, we produce back the majority of the CO2 that's injected, but then it can be re-injected one more time, and at the end of the process, it will stay in the ground. The flooding process is a continuous flooding where we inject in one well and produce from the other. And this way we can store more in the ground because you do not produce majority of the gas. And that's what is being done in Weyburn and other places. So thermal processes. So a lot of oil in Saskatchewan is very heavy. You can see this image on the right top of my screen. The oil does not flow very well. It's almost like molasses. And in fact, some of the oil is really heavy at room condition. It looks like bitumen. It's a paste. It will not flow. So we have to warm it up in order to be able to produce it. And typically, that's currently being done by steam. And you would have seen some of the boilers, and perhaps you've heard about steam-assisted gravity drainage. So what a lot of research is going into right now is how to reduce the amount of steam or amount of energy that we need to add to generate steam, because most of the steam is generated by burning natural gas, and of course that produces emissions. So one way is to co-inject the flue gas, so the CO2 that's produced during steam generation, into the reservoir. And another way is to replace some of the steam with solvent or another gas. And that again could be CO2, could be hydrocarbon. And there's a lot of different processes that are being developed in order to do that. Several companies have already been able to reduce emissions by more than 80%. So the industry is moving towards this, and again, we have several research institutes, including Ptrc, that's looking into accelerating that. So this is what a steam chamber looks like. You can inject through one valve, and it rises up, and then it drains down, and you produce the oil. So what else? Well, there's a lot of other innovative ideas there. Nanoparticles, microbial, electrical heating. I already mentioned downhole steam generators, using geothermal energy, a variety of hybrid processes, or even generating hydrogen in situ. You can actually break the oil down into hydrogen and other gases, and then produce only hydrogen. And that's what Proton Energy is trying to do right now. So there is a lot that can be done, and a lot of bright minds are looking into this in Saskatchewan. So just this is my last slide. So if you were to to set out to design an effective EOR process and reduce environmental impact, so how would you do that? Well, again, it's important to be able to use existing wells and design a process that can produce more oil from existing wells, existing fields, so we don't waste that. Again, use solvents instead of heat. Sometimes you can also use chemical additives that reduces the amount of steam and the amount of energy that you need to input. If you have to produce CO2, inject CO2 in the reservoir. That could be the CO2 you generate, or CO2 from a chemical plant, or from a power plant. Again, that's what's being done at Boundary Dam. And understand the reservoir and the process through geomodeling, laboratory modeling, and simulation. And on the screen here, you see some of the examples of the physical models that we do, that we use at Ptrc to try to understand the reservoir, test the processes, and accelerate development of new ideas such that they could be used in the next few months or years to reduce the impacts and maintain oil production in Saskatchewan. So that's it for me. Thank you for tuning in.
Okay, Erica, we'd like you to go next. I'm just going to step in for a second and just say to people, Erica's presentation will probably take us to the end of the time, but we will hang around to answer about 4 or 5 of the questions that have been sent to us electronically. Anybody who can't stay past 11 o'clock, we will send answers to these questions, as well as listing the questions, provided the individuals who ask them are willing to have us do that, to you via email. So go ahead, Erica. Thanks.
Okay, thank you, Norm. So I'm Erica Emery. I'm with the Saskatchewan Research Council. And as Norm mentioned, we are here at the last portion of the presentation. I'm going to briefly touch on methane regulations. I think in the interest of time, I will actually skim through those very quickly. And we'll talk a little bit about why methane is the focus for oil and gas, and some different mitigation strategies. So methane regulations are both federal and provincial. Federal regulations are through the Minister of Environment and Climate Change Canada, The big takeaway here is that they have a goal of reducing methane emissions from 40 to 45% below 2012 levels. Greenhouse Gas Pollution Pricing Act was introduced in 2018, and that is the carbon tax that I'm sure you're all aware of. It started at $10 a ton. It's increasing, started at $20 per ton of carbon dioxide equivalent, is increasing by $10 per year to hit $50 per ton in 2022. And there was a recent announcement in the news about the intention to increase that price even further. In November, it was also announced that Saskatchewan, Alberta, and BC have all reached equivalency agreements on provincial methane regulations. So the regulations of those provinces applies in place of the federal regulations. Saskatchewan's regulations are put forward in the Methane Action Plan, part of Prairie Resilience Climate Change Strategy. The Oil and Gas Emissions Management Regulations, OGMAR, is the program, and we can send out a link to that if anyone wants more information. Again, the main takeaway is the goal to reduce methane emissions in the oil and gas industry by 40% between 2020 and 2025. It sets a specific target of 4.5 million tons of CO2 equivalent annually. And there are phase-in starting in January 2020, increasing requirements year on year. It's a results-based standard. There is no option to not comply with this standard. It's something that you must do to operate. Also, as part of Saskatchewan's emissions regulations, there's the output-based performance standard, which applies not just to oil and gas, but to all large emitters in the province. And I am going to just move quickly past that and start talking about methane. You might wonder why I'm focusing so much on methane when this is the emissions reduction talk. Well, methane is a part of oil and gas production. So as Eric and Norm showed you in their presentations, an underground reservoir contains oil, but it also contains water and it also contains natural gas. The amount of each one is dependent on the formation, the age, geology, history, a lot of factors that we're not really going to go into. But the important thing to know is when you're producing that oil, you're not just producing oil, you are also producing the water and the gas. Natural gas or produced gas in Saskatchewan is mainly methane. There can be a little bit of other contaminants in it. So sometimes there's going to be carbon dioxide, there's going to be some higher hydrocarbons, there might be some H2S or sour gas. The key sources for emissions from oil and gas production, there's several of them, and they have varying degrees of importance. You may have heard us talk about fugitives. Fugitives are an unintentional leak that's coming out somewhere along the process that perhaps the producer is not aware of. There's also production venting, which is something that the producer is aware of. So they're producing this gas and they're separating it, and they're either venting it or flaring it. They know that gas is there. There's also venting from pneumatic devices. So instrumentation, some different valves operate using compressed gas to open and close, and those will all vent gas as part of the normal operation. There's venting from compressor rods, and there's also venting associated with fracking. Let's come back around to why methane. Methane has a global warming potential of 25 times that of carbon dioxide. And I won't spend too much time on that. We'll move right on to what can we do about it. Well, if you think back, I mentioned there's several different sources of methane and they'll have different mitigation strategies depending on your source. When we're looking at fugitives or those unintentional leaks, you want to apply leak detection and repair. There's different methods of doing leak detection and repair. Because methane is a gas, it's difficult to detect just from walking around and looking, but there are fixed gas sensors that you can install. There are optical gas imaging cameras that you can send out with an operator into the field and use this special camera to see where the methane is leaking. You can also attach sensors to mobile technology, such as on a truck or on a drone. The picture here in the corner is a test that SRC did with an unmanned aerial vehicle. holding some different sensor packages. So you can fly that over your site and do a survey of where those leaks are coming from. And satellite surveys are also being offered now. But that takes care of the fugitives. Pneumatics, as I mentioned, emit gas as part of their normal regular operation. There are things you can do about that. There is replacing your higher bleed pneumatics with newer, lower bleed pneumatics. You can also go to electric operation on your site so that you don't need to use pneumatic valves anymore. You're using electric valves, electric actuators. Compressors, same thing. It's a known source of leaks. It's a relatively small source of leaks. New compressors are being designed to reduce that leakage. You can do regular maintenance on your compressors to reduce that leakage. So the main thing that we haven't talked about yet is the methane that's produced as part of your oil production that you could be venting or flaring right down. So the normal methane that comes up out of the ground with the oil and the gas. And what are our options for that? Well, you can capture or convert. Do something with that methane. The first option that everyone thinks about is conservation. So is there a way to capture that gas and sell it? There are options. There's compressors, there's natural gas pipelines, there's a virtual pipeline where you capture the gas and compress it and transport it by truck or by rail. There's vapor recovery units. There's also enhanced oil recovery by reinjection. Several advantages for these options. Emissions are almost completely eliminated. As I mentioned, there are still, compressor packing, for example. If you're compressing it and injecting it into a pipeline, you'll still lose a little bit, a few fugitives and compressor, but you're no longer venting. Another advantage, the gas has value. You can sell it. It can be used to heat homes. It can be used industrially. Disadvantages, often transportation costs are too high. So if you are operating your well and it's producing gas, but you're a long way away from any existing pipelines, to build that infrastructure, to build that pipeline for a long, long distance to connect to existing infrastructure is going to cost more than the value of the gas that you can sell. And as we looked at too, the production decline curves are such that if you drill your well and you find you're producing a lot of gas, by the time you build up this other infrastructure, your gas production might have dropped off. Another popular option for dealing with methane is combustion or flaring the gas. It can be done with a flare, an incinerator, enclosed combustor, catalytic combustor. So there's different options here, but they all accomplish the same goal, which is to burn the gas. This doesn't really seem like a good mitigation option, but if you think back to that 25-to-1 ratio of the global warming potentials, it does help from an emission standpoint because you're converting higher emission methane into the lower global warming potential carbon dioxide. Combustors, flares, incinerators are fully commercial. They're available. They're out there right now. They're 99% efficient in general, can be quite low cost, and they can handle ranges of gas across the way. So if you have a clean, high methane gas, or if you have a contaminated gas, it will still burn. Some of the main disadvantages is that you're not producing anything. You're just burning the gas to get rid of it. And a lot of the regulations that are coming out are specific to venting, but some of them are mentioning venting and flaring. So it's not necessarily something that will be able to continue long into the future. So if you don't want to burn your gas and you can't connect to existing pipeline or infrastructure, what are some other options? You can convert it. And converting to power is one that has been gaining a lot of interest lately. SRC has done some work on this in the past and is currently involved in a study right now. There's a lot of different options technology-wise when it comes to converting gas to power. There's combined heat and power engine generator sets that you've probably experienced in other areas. And then there's smaller scale versions of things that exist in large scale, like a microturbine compared to a regular steam turbine, organic Rankine cycle, thermoelectric generators. There's also emerging technologies that I didn't really mention on here, such as fuel cells. Some advantages, you are producing a saleable product. You're producing power, which you can either use to offset your own power use on site or potentially tie into a grid, depending on the location. These gas to power technologies tend to be relatively small. They're scalable down to individual wells in some cases, or into multi-well batteries in other cases. As I mentioned, it's generally familiar technology, engines, generators. These are things that our operators know how to deal with. So there are some disadvantages. Often they require some kind of gas pretreatment. The gas has to have a minimum heat content, a minimum pressure. They can't handle contaminants. And of course, cost is going to be the story throughout this disadvantages of all the technologies. We can also convert gas into liquids. There are several different processes converting gas to liquids. It can be converted into longer hydrocarbon chains, so into a fuel like diesel or like gasoline or like jet fuel. It can also be converted into completely other chemicals, methanol, dimethyl ether, ammonia, formaldehyde. And they all have different processes, but they have some similarities. They all produce liquid fuels or chemicals, which can generally use existing infrastructure. So if you're already pumping oil away from your oil well, and you can produce more oil or more gasoline or more diesel, then that's quite easy to handle and deal with. Most of these, not all, but most of these are commercial at large scale, but a disadvantage is the scale down is still not quite there. So they require a large quantity of gas. The smaller you try to scale these down, the less economic they tend to be. They have high capital costs. And these technologies will require a full-scale chemical plant. So this is like refinery-sized equipment. This is not something that you're going to put on every single one of those dots on that map with thousands of dots on it. So to summarize quickly here, I see I'm out of time. Methane regulations are in place with the goal of reducing methane emissions from the oil and gas industry by 40 to 45%. Methane mitigation strategies, you can do leak detection and repair, you can do pneumatics replacement, you can try to conserve the methane, combust the methane, you can produce power, you can produce liquid fuels and chemicals. All of these have their different advantages and disadvantages. And SRC is working with producers and technology companies to reduce emissions through our Center for the Demonstration of Emissions Reductions. Thanks, Norm.
Okay, great. So as I said, we have reached 11 o'clock. We're hoping people can hang around for some of the questions because we've got about 10 of them and some of them are very good. I'm going to either Zainab or I can get our experts to answer some of these. I'm just trying to find, oh, there it is. Sorry. Just making sure I can see the questions. Eric, do you want to address, there was a couple things that Jane raised, a few questions about fracking and how that fits into this. I think we have had a few slides on fracking, but also about cement casing and why is it cemented? Does it protect from contamination? Can you talk a bit about that?
Sure, I can speak about that for a minute. I've answered it in the Q&A section, but just to reiterate, the cement is there, you know, to solidify the bond between steel and rock. You've got this space between the casing and the rock that is called the annulus. And what if you didn't cement it, there'd be potential for fluids transferring from one formation to another, or there'd be potentially fluids coming from the reservoir going into another formation, or even right to surface if you didn't cement it in. So, you know, just to get into a bit of detail on how this cement is put in there, it's pumped down the middle of the casing with a rubber plug behind it, and then that rubber plug is pumped down, and all of the cement goes to the bottom of the well and up around the sides and cements it solidly in place for the protection of the environment, but also to increase the efficiency of the oil well.
Great. So one of the other things, and of course, because we did have some slides about fracking, and of course, Petro, you're welcome to jump into this too. I know there are people who have had concern in other parts of the world about hydraulic fracturing and the fact that the fractures may reach up into other zones or, you know, into drinking water. What is fracking? And maybe you can talk a little bit about what depths it's done in Saskatchewan and why it's different here as opposed to maybe other places where they're fracturing higher up.
Yeah. Speaking for Saskatchewan specifically, the fracturing here is done mostly for the Bakken Reservoir, and the Bakken Reservoir sits at about 17 or 1800 meters. And what they're trying to do there, fracking is in essence trying to improve that porosity and permeability in the rock right at the outset. So from initial production, they want better flow into the well. So how you can fracture that rock, and this is not a new technology, it's been done since the 1960s, I'm sure, is you pump water, sometimes a thickened water thickened with guar gum or a polymer of some type, into the reservoir at a very high pressure to the point where you reach the fracture point. And what the fracture point is where that fluid pressure increases the amount of pressure that's holding the rock together. And what happens is you induce a fracture. And what you have to do, and if you reduce the water pressure after that, that fracture would shut immediately. So what you pump in along with that water is a little bit of sand called proppant to prop open those fractures and keep them open. And what that does is that allows you to access more of the reservoir. Now, I know there are concerns and examples where fracking has gone very wrong. At the depths that we have it in Saskatchewan here, that is not a problem because the fractures only go out maybe a few tens of meters from the well. And they are especially trying to not have them go upwards at all, because what that would do would access a different reservoir perhaps, and one that would bring water into the oil well and essentially ruin it. So it's in the company's interest to have these fracs be very controlled in the way they do it. Now, I can't speak for other places in the United States and that, but at least in Saskatchewan, fracking has been shown to be a very safe and effective way of increasing production.
Great. So we do have a question about methane and whether or not it can be used in enhanced oil recovery. And I thought maybe Erica or Petro could answer that. It was just a basic question. Can you use methane in the same way you can CO2 in reservoirs?
I'm gonna throw that one to Petro.
Okay.
Sure. So Eric already answered it a little bit in the Q&A chat, but the answer is yes, and it is currently being used. It's not as good as CO2 because it doesn't have as much solubility in oil, and it cannot become miscible at most reservoir pressures. But what it does, it provides pressure to the reservoir, so pressure support. So that Coke bottle is still going to be under pressure, and it's easier to recover oil out of that. So the answer is yes. Okay,
good. Now there's one that I haven't typed an answer to, and it's from Corey Brandvold, and he's wondering if the energy released that currently isn't being used. So he's talking about methane with flare stacks and venting. Could that be put towards some sort of energy input? And he said, I know propane is a byproduct being bottled in my area. What about using the flared and vented gas towards heating in some way? I suppose an easy answer might be that there's not enough to make that economic if you have to try to put it in, but maybe you could answer that, Erica. Do you know whether there's some movement towards that?
Yeah, that's kind of the short answer. So yes, it is methane, and it can produce heat and it can produce power like I talked about. So if there's enough gas or there's existing infrastructure, you can conserve that gas and sell it into the natural gas pipeline and then use it. If he's asking specifically about can you capture heat from the flare and use that heat, that becomes an issue of location. Transporting heat between places is quite difficult, so you would want to be using the heat on the site. Now, some sites do have heated separators, so there might be a little bit of use for heating your oil after it comes out. But it's much easier if you want to make use of that heat to just capture the gas and then burn the gas at the site that you need the heat.
Okay, good. Just by the way, there will be the recording of this webinar will be put up at the PTRC YouTube page. I think you'll receive an email about that as well. I'm just looking here for another question that I saw, and just a second. Pardon me. So one person asked whether it's an actual geological question, Eric, about because I think he works in the field of the exploitation of uranium and other resources. He's a geologist, and he's wondering to what extent the oil reserves and the oil deposits in Saskatchewan are considered world class, or whether they're just kind of a pale cousin to Alberta's, I suppose you could say.
Yes, I saw that question. It's an interesting one. And Dan, you may want to jump in on this as well, as Dan has worked in probably some of the true world-class deposits. You know, beyond Weyburn, I would say Weyburn is an example of a world-class EOR project. And that's something that doesn't go on very commonly in the world. And I think you can look to Weyburn as being world-class. Beyond that, though, if we're measuring this just by sheer volumes of oil produced, no, we're fairly far down in the world, probably in a lot of things, and below Alberta as well. Dan, do you have any comment?
Well, you can look at it from the perspective of how much oil does Saskatchewan produce. We produce somewhere around 488,000 barrels of oil a day. It's about 10 to 12% of the total production from Canada. So it's not significant in that sense. In terms of the size of the resource, Alberta obviously has the oil sands resource, which is just absolutely huge. We don't have that oil sands element here in Saskatchewan. We do have the cold heavy oil production, though. In all, and I don't want to get too long-winded in it, we've got something like 55, 60 billion barrels of oil in place, cumulative with heavy and light oil. That's not insignificant. And the point that we've been making through all of this, the most that we seem to be able to get out of that is around 10%. So we're leaving 90% of it behind. It's substantial, it's significant, and we think that the kinds of technologies that we've been talking about here today are most applicable here in Saskatchewan. So is it world-class? Maybe not, but is it significant? Absolutely.
Good, thanks. There are some questions we're simply not going to get to. There's a really interesting question from someone in India. I think I'm going to leave that for Petro to respond via email on that. And as well, there's a question that's just a general one about whether nanotechnology is being used in EOR. And I can safely say that yes, it is, but I don't know that we have time to get to that one today. I would like to ask Gary Proshin's question, unless that was just answered. Did you just type an answer to that, Eric? Looks like somebody did. He's talking about wells. There he is. In Weyburn, he says, I'm not sure I fully understand this, but it's a good question. By the way, we'll stop at 11:15, so we have another 4 minutes that we'll go through some of these questions. In Weyburn, stainless steel tubing is used. What is the life and technical risks plus economic concerns of this? He said, I know in the Philippines with geothermal energy, this is an issue. So I'm assuming maybe he's talking about corrosion. I'm not sure. Also, offsetting oil wells. Is there any protection for offsetting wells not in the CO2, and are they protected? So I believe Weyburn did do some research into wells, didn't it, Eric?
Yeah, there's been extensive research into wellbore integrity, I guess is the broad field of study, and looking at what happens to, you saw that Weyburn was drilled in the 1950s, and there's a lot of really old completions there, and there was a lot of concern around what will CO2 do to that casing, and you know, it took a long time just to even catalog all of the different wells and the different types of completions that they have. In essence, if the cement job is done well and done right, the wells are not exposed to the CO2 for old wells. For new wells, yes, stainless steel or coatings were used on a lot of the equipment there, and a lot of the surface pipeline and all the surface equipment has special coating on it. And as for economics, yes, that does indeed change the economics, I would say. The preparation that would be required for taking a field from the 1950s and bringing it up to date to perform CO2 EOR on would be significant, and would need to have protected tubulars like that. I don't know if Petro or Dan, you have anything to add to that.
Covered it well, Eric.
So one other interesting question that we got, you know, if the carbon tax goes up to $50 a ton, one of our viewers said, well, you know, if a barrel of oil produces, let's say, half a ton of CO2 when it's burned, at what point, if an oil company is being penalized for producing that barrel of oil, does it become uneconomic to continue to produce oil if they're paying a $50 ton per $50 per ton, and a barrel of oil is producing half a ton? I would think part of the mix in that would be if you're storing CO2 by producing that oil, then you're reducing the amount as well of CO2 that's part of that footprint. But I'm not quite sure I understand the question, but I think the basic idea would be that, you know, if the carbon tax goes high enough, does the production of oil simply become unfeasible if oil companies are having to pay that tax?
Oh, okay. There's many parts to the answer to that question. What drives the economics of the industry obviously is the demand for the resource and the commodity price. So that is the first thing that a lot of companies look at. The other thing is the operating costs in general. What does it cost to produce that barrel of oil? And the cost of carbon becomes a key part of that. What is the right answer there? That's something that that companies are looking at and looking at what they need to do to manage their business effectively. The cost of doing business going forward is going to be involve having to deal with CO2, cost of carbon. There are a lot of companies in Saskatchewan who are involved in what is called SAGD. You heard that term. It requires you to generate steam. You'd have to burn natural gas to generate steam. A lot of companies are looking at how can we recover the CO2 from burning natural gas to generate steam. And then what do we do with that CO2? Can we put it somewhere? Can we store it? So that becomes part of an economic analysis. Then extending the life of these older oil and gas reservoirs. If CO2 were to be delivered to their doorstep at a price that would be attractive to their continuing business, would companies be interested in doing that? These are some of the bigger questions that are being asked right now. And let me add this, because this is really important. You've heard a lot about the federal government investing in blue hydrogen these days in Alberta. Well, the reason it's blue is because the hydrogen is generated from organic or hydrocarbon systems. There is a lot of CO2 that is being produced. The Alberta Carbon Trunk Line system was built to transport that produced CO2 into, of all places, EOR projects. We see that as an opportunity, and PTRC, the province of Saskatchewan, has been way ahead of the curve on that. We have Weyburn CO2 EOR project. We have the Aquastore project. We have opportunities, we believe, to use CO2 in other enhanced oil recovery projects, connect with the Alberta Carbon Trunk Line system. So we've been ahead of that, the province, SRC, the universities, and so that's what we're looking to provide the understanding of the technology of how this thing will work in order for companies to make these kinds of business decisions.
Good, great, Dan, thanks. So I think I will wrap this up and I'll let Dan have a few closing comments. I just wanted to say that you will, when you log out, you'll be taken to a page that is just simply a 3-question survey. If we did not answer your question in quite the way you'd hoped, or if we didn't get to it, because there were a total of 15 questions, I don't think we got to them all. We tried to type responses. You can retype your question. There's a field, the 3rd question lets you put your question back in, and those are sent to me. So I will endeavor to try to get you a written response to those questions. Please do the survey. It's really quick. It's like click here, click there, type something in if you want. Aside from that, we will be posting the complete webinar at the PTRC YouTube page. Please do visit both our YouTube page and SRC's. They have some great videos there that explain a lot of the science about what they're doing in all of their research areas. They're doing agriculture. They're going well beyond oil and gas at SRC and what they do and what they cover. And aside from that, thank you very much for attending. Dan, did you want to have a few closing comments?
Yeah, thank you. So the PTRC just happens to be sponsoring this webinar. What I want to leave you with is that we are part of a network of research organizations here in Saskatchewan who are committed to the sustainability of this resource industry and reducing emissions. That work includes the SRC. Thank you for being part of this. The CCS Knowledge Center, who are focused on carbon capture, and then the research organizations at the U of R and the U of S. We all actually collaborate quite effectively together, but we also collaborate with other jurisdictions, in particular Alberta. There is no homegrown solution here. This is an industry that requires solutions from all different parts. And PTRC, the SRC, the Knowledge Center, we're all part of that network. So I want you to understand that we may be a small province, but we're hitting above our weight here when it comes to being involved in this research to make our industry sustainable and reduce the emissions associated with it. Thank you, Petro. Thank you, Erica, Eric, and Norm for your presentations. And yeah, if you have more questions, please feel free to reach out to any of us. I would be happy to answer them.
Thanks, Dan. And also I'll say thanks to Matt and to Zainab for monitoring our questions and answers for us, and Suzanne for helping to contribute towards setting up my survey and some of the other aspects of this particular meeting. Thank you, everyone. Have a great, heading into the holidays, have a great holiday. And we will endeavor to respond to any of your questions if you feel they weren't responded to in full. Thank you very much, and have a good weekend, everybody.